Hello, everyone. It's a pleasure to be here. Thanks, Matt, for inviting me and the team for organizing the conference. I'm Henry from Central, coming over from Hamburg, Germany. And at Central, we're building a platform for GitOps and API-driven device management that helps organizations to meet their compliance goals. And in my session today, I'm going to demonstrate how we use Munki with a Mac security compliance project to achieve a high level of compliance. Nowadays, organizations of any size, regardless of regulation requirements, have to implement security measures to harden their devices and report regularly on the compliance of their fleet. And in this talk, I will show how we track compliance of our devices in Central and demonstrate how we implemented the mSCP guidance. But first, let's start with a quick recap on what the Mac Security Compliance Project is and why it's so important for our community. For many years, the National Institute of Standards and Technology, short NIST, had been publishing secure configuration guides for macOS system versions, and these guides were long-winded PDF documents in Security Pros. And admins who had to implement the guidelines had a lot of work on their hands. They had to maintain maybe big Excel sheets to keep track of the controls they wanted to implement and how they translated them into configuration items for their management tool. To be able to update the guidance for the new OS versions quickly and to facilitate the adoption of NIST of those guidelines, they started a new initiative in August 2019, the open source macOS Security Compliance Project, short mSCP, which is maintained on GitHub. The first commit is almost 4 years old now, and the security guidance is written in a machine format in YAML. And the tools are provided to customize the settings, selection, and to automatically output scripts, documentation, and configuration profiles to be used on macOS. And thanks to its versatility and extensibility, this project has quickly become the de facto standard for hardening macOS clients and is even part of the macOS or of the Apple platform certifications documentation. So some vendors have made integrations available for the management products. Let's look how we implemented the mSCP for our own macOS client. Our Apple device management software Central has a built-in mechanism to track the health of devices, which is the compliance check. And a compliance check tracks the compliance of a machine with a single control, and for each machine and for each control, the status of the latest check is tracked. And there are different control types available in Central, each contributing to the health of the device. Here's an example of a compliance check that is based on inventory data. You can see a JMS path expression that is evaluated against the full inventory tree every time the inventory information is updated. And this inventory compliance check simply makes sure that OS query is present on the machine. So, for more complex requirements, we can use OS query for compliance checks as well. So here's another example. And with that query, we're comparing the expected version of Google Santa, of the security extension, with the ones currently loaded and activated on the device. And a special column named ZTL status is used to report the results OK or failed here. And when we wanted to implement the mSCP controls, it would have been possible to translate some of them into OS query queries and run them with the Central OS query compliance checks. But because the OS query tables do not contain all the information we want, this would have been a tedious process, and the coverage would be far from satisfying. So we needed a mechanism to run the mSCP scripts to cover all of the controls in the mSCP, and we decided to integrate this functionality with Munki. Central already gathers Munki logs and inventory information using custom pre- and post-flight scripts. And we developed a new kind of compliance check in Central called the script check. So they are scoped with machine tags for inclusion and exclusion, and they can be also restricted for specific architectures, like Intel and ARM and OS versions. They are built to run the mSCP scripts ad hoc, and support a standard environment variables like the current user and current user ID. And the scripts will run Munki post-flight, during the Munki post-flight. And the run interval can be customized to avoid running them too often. The results for each script check are uploaded to the server where they're stored, processed and aggregated like the other compliance checks. And we maintain our own central configuration with Terraform and GitOps workflows. And we didn't want to make an exception here for the script checks. So remember, the big advantage of the mSCP project is that the controls are written in a machine format. I presented a lot about the GitOps workflows last year right on this stage. And now let's look into a short demo how we create our Terraform mSCP resources. When organizations want to implement the mSCP, you will have to create a security benchmark. And a benchmark is a set of controls with defined target values assigned to them. So the controls are part of a catalog of recommended settings of a baseline like NIST 853 or CIS or others. And an organization can define their own benchmark by making a selection of controls from a baseline and assigning organization-defined values here, or ODVs. And the ODVs define custom values like strings or lockout timeouts. And for example, this ODV here configures the time server. And now, when we have all the rules selected and our ODVs set, we want to turn this into script checks. And because the mSCP is machine readable, we were able to write a tool that converts our custom benchmark, which is our selection of our controls, tailored from the CIS level 1 baseline, and the ODVs that we have defined, and turn them into Terraform resources. So let's see how this tool works. When we run our tool, that starts here, we can see that it logs the values of the ODVs. So we should see the time server, ODV, and we should see, let me scroll higher up, the hello world message, and several other ODV values that we've set. And when we go back, we see that we've created a Terraform file with our mSCP custom benchmark as Terraform resources for all of our selected controls. This means we can commit these resources into our central configuration repository, can make pull requests, verify the changes that this introduces, and make code reviews, and merge it into the main branch, and then deploy the script checks to production. So let's take a look into some of the mSCP Terraform resources that we've created. So we can look up for some very well-known one, like the file vault enforcement. And you should see this here. And you should see that this is the default mSCP script used here. And we're looking for our expected result. And then we verify another one, which is the time server ODV. And again, same thing, standard mSCP scripts and the expected result. And finally, we also check for our demo login window, hello world message, which is in base 64 encoded. So once we have deployed this through our CI/CD pipeline, our script checks become active in Central. So we can find them in the web UI, and they almost look the same as in our Terraform file. So this here is an mSCP-based script check that we have deployed that runs via Munki, checking for our login window message. And this is a base 64 string that we see as the expected result. But remember, compliance checks can be also based on OS query, like the one we've seen before. This here checks for the team ID and the identifier and the minimum version of Santa, which is the endpoint security tool. And all these compliance checks run across our fleet in the form of individual checks. And in this context, let's talk about reporting, metrics, and events. Every time the status of a single control for a machine changes, Central will emit an event. And this here is an event for the Munki script check. And this is an OS query compliance check event. And the statuses for each control are aggregated and contribute to the health of the machine. And we publish the metrics to track each control that we aggregate over time with Prometheus. And then we use Grafana for our dashboards. But you could use any other standard tool that works with Prometheus here. Prometheus and Grafana work out of the box and are part of every standard deployment of Central. And they come with a set of default dashboards that we've built that you can customize and tailor to your needs. So, for example, in this Grafana dashboard, we can see all the compliance checks in one place, and it allows us to see how things have been changing over time. And you can see that the mSCP checks go along with the other compliance check types. So it's a long list, almost all green. And when we go to the central inventory, we can drill down and add a filtering based also on the compliance checks and get a list of matching machines as a result of our filter. So, and there's a list of devices when we scroll down. So now that we have the tiles and the filtering applied, we can create a report to export the results of this filter, or you can use the inventory API to get the data out of Central, including those filters or the full inventory. But there's one more thing to talk about, which is remediation. We've made some experiments with Munki no-PKGs that we use to remediate failing controls. A no-PKG is a Munki package without actual software, and it's only the metadata with the install check script and a post-install script. And here you can see the no-PKG that we use to switch off the HTTPD server. Okay, and in the install script check, you can see this is the default mSCP script, a very short one, and we just have to make sure that it will exit with an error when the machine is compliant. So this is something special. And I can tell you from experience that this is easy to get wrong. It's only when the install script check will exit with a 0 that the installation, the remediation here, is triggered. And in the post-install script, we have the remediation, and this flow will be executed during each Munki run. So, very quick one. Thank you for listening for this short talk. I hope I could illustrate how useful and versatile the mSCP project is and the kind of integrations and results that it enables. So how we do it, how other people do it. So there's a lot of potential in here. And of course, Munki, who is now 14 or 15 years old, continues to be this extremely powerful tool. And not only for keeping third-party software updated, but Munki is, in our opinion, the indispensable companion to the Apple MDM agent. And thanks, Matt, for having me over for this talk. And thank you all for listening.